Okay, let's continue with this next example. We want to determine the vertex for this quadratic function, and again, apparently when I PDF these they didn't come through very well, so it's a 4x squared plus 16x plus 1,000. So let's find the vertex and state if the vertex is a maximum or minimum and find where that occurs. There's our function, so we just want to find the vertex here. So let's work on the formula to find the vertex, which is negative b over 2a. That will calculate our x-coordinate. So for this function, negative b will be a negative 16. 2 times a will be 2 times 4. So negative 16 over 8 is a negative 2. So there's the x-coordinate. Let's find the y-coordinate. And the y-coordinate is found just by plugging in a negative 2. So 4 times negative 2 squared plus 16 times negative 2 plus 1,000. What's that going to be? 16 minus 32 plus 1,000. So negative 16 plus 1,000 will be 900. And let's say 84. 16 will give me 1,000, yep. So the vertex, which is what we want to find, is negative 2, 984. Let's determine if it's a max or a min. Since this one is opening upward, that vertex is a max, is a min. When it opens up, that vertex is a minimum point. And let's find the max or minimum and where it occurs. Well, this is where it occurs, and the maximum is 984. So it occurs at negative 2, and the minimum value is 984. Okay? Last thing is to look at some applications. What we're going to notice, I only picked a certain type of application for these to look at. They had several, and I was just trying to streamline for this summer how I wanted to do it, so I only picked a certain type. But what you'll notice in the applications is they will always either ask you for a min or a max, which means they want you to find the vertex. And we've already figured out how to find the vertex in the two situations we saw earlier. So we'll work on basically just finding a vertex. Now this function is actually 0.4x squared minus 36x plus 1,000. There's our function. And let's just go ahead and read the situation. It says this models the number of accidents per 50 million miles driven for drivers who are X years old. And notice what they put. They put a constraint on the age for the drivers, and the age that they're looking at is between 16-year-olds and 74-year-old persons. So X will go between those two values, so they just put a little restriction. We want to find out the age of the driver having the least number of car accidents and the minimum number of car accidents. Notice that key word, minimum. That means we're wanting to find the vertex. That means find the vertex. And then we'll interpret what the vertex tells us. Well, let's go ahead. It's in the format where we'll use the formula. For the x value, it's negative b over 2a. And negative b will end up being 36. And 2 times a will be 2 times 0.4. So it'll be 36 divided by, let's go ahead and pull up the calculator. Let me clear this out. And when you're doing this in your calculator, make sure that you use parentheses. Watch what I'll show you what I'm talking about. 36 divided by, okay, it's running a little slow. I'm going to use parentheses because, let me take a quick look, it was 36 divided by 2 times 0.4. So 36 divided by 2 times 0.4. Notice I put 2 times 0.4 in parentheses. You have to do that, otherwise it won't make the calculation correctly. So we come up with 45. So 36 over 2 times 0.4 is equal to 45. So there's the first part of my vertex. Let's plug it in. So it'll be 0.4 times 45 squared minus 36 times 45 plus 1,000. Let's go to the calculator. Put that in. Find that value. Let me actually put my equation over here so I can do it. There we go. So it'll be 0.4 times, parenthesis 45, close it, and squared, minus 36 times 45 plus 1,000. Let's enter that and find the value. So the value we come up with is 190. So let's interpret this. What does 45 represent? Well, it's my x coordinate, and the problem said x represented what? X years old. So x is the age. F of x is the number of accidents, or that's our value for y. So let's answer the questions. What's the age of the driver having the least number of car accidents? So that 45 is the age they're asking for because it's the x value. And then they're asking what's the minimum number of car accidents? This is the minimum number of car accidents. So that's the age that gives us the minimum number of car accidents. And the age is 45 and the car accidents is 190 there. Let's do one more application. Formula for this one, or the function for this one, is negative 0.002 x squared plus 1.4x minus 400. And let's see what this represents. It's the profit that a vendor makes per day selling pretzels. Okay, so x is the number of pretzels, f of x is the profit, and we want to find the number of pretzels that must be sold to maximize profit. There's that word, maximize. Maximum or minimum means we need to find the vertex. Pardon me about that phone. I'll just have to sit on it for a while. So we want to maximize profit, which means we want to find the vertex. And because it's in this format, we're going to need to use the x value for negative b over 2a, plug it in to find the y value. So let's work on the vertex. Negative b over 2a is going to be negative 1.4 over 2 times negative 0.002. So there's negative b over 2 times a. Well, let's calculate that. Negative 1.4 divided by, and let's use parentheses for the denominator, 2 times negative whoops, 2 times negative 0.002. So negative 1.4 divided by 2 times negative 0.002 will give me a value of 350. So the x-coordinate for my vertex is 350. Now remember, what does x represent? If I go back to my problem, x represents pretzels. So I've got 350 pretzels. what's the question that they're asking? And I'm going to check that out first, because if I don't have to find the y coordinate, I'm not going to go ahead and find it. They want us to find the number of pretzels that must be sold to maximize profit. This answers their question. 350 pretzels will maximize profit. Now, they don't ask us for it, but let's go ahead and find the maximum profit if we sell that many pretzels. So to do that, all we do is plug in the 350 into our function. So negative 0.002 times 350 squared plus 1.4 times 350 minus 400. So let's go to the calculator and put that in. So negative 0.002 times 350 squared plus 1.4 times 350 minus 400. Oh, now I remember with this problem. I pulled this problem and I copied something wrong, so we don't want to find the maximum profit because there is something wrong with the way I have the function written. Oops, so yeah, now I remember doing this one in class and saying, oh, forget about that because my function's not right. Well, so let's scratch that out. The main goal, because we don't want to have a negative profit. I mean, we don't want our maximum profit to be negative. Anyway, bad choice of function for me, but we can answer the question and go through the mechanics of the maximum number of pretzels would be 350. So sorry about that. In solving these application problems, those are the only type that I picked out. So here is just a strategy for solving those. Read it carefully. Always read it carefully. We're not going to worry about that because the function is going to be given to you. Don't need to worry about that because it's going to be in that format. But we do need to calculate the minimum or the maximum value and answer the question. So you can look at the applications and the technology problems. Be good to pull out your calculator and start playing with it. And do the homework in Course Compass. If you want extra problems, you can do these from the book. But these applications and these technology problems you will not see in Course Compass, so I suggest that you do those from the book.